So, welcome to module 10.6. In this module, this is the last of the module related to the compiler theory part. We will now see how do we handle arrays in the how do we translate array type of statements onto the VM code. So, that is what we will be seeing as a part of this module. So, there are two parts of this array. One thing is we have to construct an array and then manipulate this array, right. So, let us see how we are going to construct array and how we are going to manipulate array. For example, we have var array arr, let arr is equal to array.new of 5. So, what essentially needs to happen is that arr is, say, let us say it is a local variable 0. So, now arr equal to array.new 5 should initially the value of arr will be 0, but once you do this array.new of 5, then this value of so the compiler should the machine should allocate 5 locations, let us say 8054 to 8058, and then update this value of arr by 8054. This is what it is supposed to do, right. So, now we will understand from the callee perspective and the caller perspective what is going to happen in this case. So, there are two virtual memory segments that can be aligned to different RAM numbers. First, let us remind this and that, right. So, this now points to 8058, that now points to say 8054 here, right. So, let us say that has 3 locations 8054, 8055, 8056. So, that 0 is that comma 0 is 8054, that 1 is 8055, that 2 is 8056. Similarly, let us say this has 8058, 8059. Now, if I want to change this 8058 value, I say pop, I put whatever value onto the stack and pop pointer 0. So, suppose I say push 10 and I say pop pointer 0, then this 3 will become 10. And similarly, if I say push 100 and say pop pointer 1, then this 4 will become 100. So, I can change the address to which this and that are pointing, namely I can change the content of 3 and content of 4 by popping to pointer 0 and pop pointer 1 respectively. This we have seen, this is just a recap what we have done earlier. Suppose I have say array of 8056 is 17, say RAM of 8056 17. What should I do? I always use this that pointer to manipulate this, because this will be always used for pointing to the current object. So, that is now will be now used. So, when I was describing this virtual machine, I said this that, don't bother now, later I will explain why we are using this and that. Now is an instance where I am going to explain you what is that. This we have already explained. Now, that I am going to explain now. So, when I say RAM of 8056 is equal to 17, what I do is push 8056. So, 8056 goes into the stack. Now, I say pop pointer 1. So, 8056 will go to this location 4, it will adjust. Now, I want push 17. So, I am pushing 17. So, what will happen? So, somewhere this 17 will get into the top of the stack. Okay. Down I say pop that 0. So, in 8056 17 will now get stored, right. So, the way I execute RAM of 8056 is equal to 17 is I push 8056 pop pointer there. So, now that becomes 8056. Now, I push 17 onto the stack and say pop that 0. So, 17 will get. So, this is the equivalent VM code for this jack level code, which is RAM of 8056 is equal to 17, right. So, now what has happened, let me just again explain to you once. When I say push 8056, somewhere 8056 gets into the stack, pop pointer 1, 8056 goes and stays now in that. Now, 8056 is this pointer to the start of that segment, that is what it means. Now, I say push 17, 17 goes on to the top of the stack. and then say pop that 0, that means 8056 plus 0, which is 8056, gets 17. So essentially I have made RAM of 8056 as 17. Okay. There's some small here, this need not be the top of the stack. So this arrow basically talks about where 8056 is there. Okay. So right, so if I say let R2 is equal to 17, right. So how do I do this? First to push ARR, push to add. When I say push ARR, what am I pushing? I am pushing the base address of ARR. When I say add 2, I add 2 to the base address of ARR. So that will be, so that add will now be the address in which I want to store 17. Suppose ARR is stored at 8056, then 8058 is where I need to store 17. ARR's base address is 8056, 8058 is where I am going to do 17. So when I say push ARR, what will go into the stack? If 8054, let us say ARR starts at 8054, if I say push ARR, 8054 goes into the stack, then I push 2, then I get 2 goes into the stack, now I add, then I get 8056 on top of the stack. I pop that to pointer 1, so 8056 goes to that. Now I push 17 and I say pop that 0, so 8056 basically gets 17. Right. So this is how I use the that segment to handle manipulate arrays. Now when we do this, then there is an issue, right. Let ARR expression 1 is equal to expression 2. Suppose I say push ARR, push expression 1, right. What will push expression 1 do? It will basically expression 1 will evaluate something, and that output of if compiled expression, suppose I do a compilation of the expression, that code will evaluate that expression. For example, ARR of ARR of 5 plus 6, so that will become ARR of 11, right. So 11 will be there. When I add this, let us say ARR is 8054, starts at 8054, let expression 1 be say 4, so 5058 will be there. Now when I pop pointer 1, what will happen? That will become 8058. Now I push expression 2, right. So I compile expression 2, so this will give an answer that will be on the top of the stack. So when I compile and execute an expression, what I assume is the expression's output will be on the top of the stack after it completes. Now when I say pop that 0, of course it will go to this 8058, but what will happen is when I am evaluating expression 2, I might go and change this that. See, what we have done is array of expression 1, let us say ARR of 5 plus 6, so 5 plus 6 is 11, ARR starts at 8054, 8065 is where I want to store the evaluated value of expression 2. That 8065 I have stored at that, I should have stored it here in that. That is what happens at the end of this four things. Okay. But then when I am evaluating expression 2, that expression 2 can now go and touch that, and if it touches that, then this value essentially will get replaced. This whole thing will, so expression 2 completes and you get some value. When I say pop that 0, that has what? 8065. 8065 will get that value of that expression, provided this expression 2 does not touch that. The expression 2 itself can be another array expression. For example, let A of 10 be equal to C of 15, right. Now that C of 15 will go and touch that. So that so what will happen is this particular code will not work correctly if this expression 2 touches that. Okay. So for example, as I told you, let A equal to Bj, push A, push I, add pop pointer 1, push B, push J, add pop pointer 1. That's all, your pointer 1 is gone, right. So if I have array on both sides ai equal to bj, then this array, this manipulation will not work, right. Now we can give all these scenarios, a of I plus a of j plus a of 3 equal to a of j plus 2, you go mad, right. So if I give some things like this, so the point is, when we have this type of an expression, so how do we do this, right. So this is what we do. So push a, push I, add, so this will give me the address in which I have to store bj, right, that will be on the top of the stack. So now let us look at this. At the end of this add, what will be on top of the stack? The address in which I have to store bj. Similarly, push b, push j, add, this will tell you the address of bj, pop pointer 1 and push that 0, that means it will get you the value of bj, right. So that will be on the value of 0. This value of bj, I pop it to a temporary location, pop temp 0. Now what will be on top of the stack? This ai will be on the top of a plus I, where I need to store that value. At that I pop pointer 1, then I say push temp 0, then I say pop that 0, right. So this is the thing that we need to do in general, okay. So I will just try and explain this a bit for you, so that you know we have a little more clarity on this, otherwise going to do. So very simple, a of 5 is equal to a of b of 8. Let me say a is stored at 5000, b is stored at 7000. So essentially means content of 7008 should move to 5005. So this is the stack, and somewhere this is, let us say this is that. So let me say this is stack that is growing. Now I say push a. When I say push a, what will happen? 5000 goes into the stack. Push 5, we said push I, right? So 5, so 5 goes into the stack. I say add. When we say add, this will become 5005, right. Now I say 5005 is on push b, so 7000 pushes, push 8 pushes, add, I get 7008. Now I say pop pointer 1. When I say pop pointer 1, essentially this will get removed, and basically 7008 will go to that segment. That is what pop pointer 1 will do. Now in 7008, let us extend this memory. Suppose in 7008 we have 15. Now I say push that 0, go to the that segment, add 0 to it, 7008, whatever value, push it back to the stack. So stack will now get 15, 15 will now move, okay. Now pop temp 0, temp is a segment from 6 or 8 to 15. So there is a temp segment. So somewhere let us say there is a temp segment here. So the temp segment, this will now pop. So 15 will now go and sit here, temp 0. This is temp 0 segment. Now this is the top of the stack. Now I say pop pointer 1. So essentially when I say pop pointer 1, again this is temp pop temp 0. Then I say again pop pointer 1, okay. So when I say pop pointer 1, what will happen? Now this will go off and this will go to this. So 5005 will get onto that. Okay, 5005 will go on to this. Now push temp 0. So this 15 will now get pushed on to this, push temp 0. Now pop that 0. Pop that 0 means now this 15 will go now and reside in 5005. So 15 now goes to 5005. So the content of 7008, which was 15, now gets copied out to 5005. Right. So this is how we basically work on this particular array access. Right. So in general solution for generating array access code, for example, let array expression 1 is equal to expression 2. So what we do is that we push array, then we put the VM code for expression 1, then we add. So the VM code for expression 1 will give the value of that expression 1 there on the top of the stack. We will add. So that is the, at the end of this, what you see at the end of this add is the which address I need to store the evaluated value of expression 2, that is will be on the top of the stack. Now I do VM code for computing expression 2, then that answer I store it in temp 0. Now I pop pointer 1 which will be this address, and push the value of temp 0 again back to a stack and pop it onto that 0. So essentially this gets. So this is a general way of handling let expression is equal to expression 2. So please note that a of I will work very nicely. So if you just code this recursively works very nicely on that. Okay. So the big picture to conclude is that there is a Jack program. Now we have done project 10, the current project 11 we have to do, that will give you the VM code, and that VM code using project 7 and project 8 we will write into a VM implementation, one of this but the same thing we can write for different other devices, could have VM code, and this will basically take it forward. So this is how the whole thing works. So and this is the big picture here. Okay, and so we will now go to module 11 where in the next week, where we will start looking at the project 11 in greater detail.